In this video, we will talk about layers in networking. So let's understand layers and this layering protocols with one example. Suppose there is one person Maria who is talking to another person Anne, and now both are supposed sitting in front of each other and they are talking. Now in this case, suppose Maria is manager or supervisor of N and they are sitting in an office. Then in this case there are certain rules or certain protocols that they has to follow, which means Maria will be asking N to like what are the task has been finished, what are the task has left, and will be reporting that what are the task has to be done, whatever the difficulties in the last task, etc. So there are certain rules under which they are talking. These rules are called protocols. So protocol is nothing but there are certain defined rules under which two-person talks. Now in this case the medium is air, which means they are just talking with a voice, and they are sitting in front of each other. They are just talking with a voice. That's why medium is air. So like this is very simple example where I just want to convey one thing, that how very simple communication can happen, right? There are two persons talking to each other and medium is here, and there are certain rules which are protocols. So this is very simple communication that you can imagine. Now let's say that Maria is in US and Anne is in India, or basically they are not in a same location. Now Maria has to send some letter to N, and now that letter will be some plain text, and then the letter suppose got encrypted, like because suppose like there is one layer or there is some person, it could be some person, it could be some machine, anything. So that is encrypting this letter, and then this letter is getting posted to N using some post office. So this is how it is being done. Now at this layer, this message get received, and then this message will get decrypted, and then this message will get delivered to N. So this is the process of one simple text message that Maria has to send to N using a US post office. So here US post is working as a physical medium. Earlier it was air, now here it is an US post, and there are different machines that are involved in this. There could be persons, there could be machines. I mean, a person could encrypt or decrypt, a machine could encrypt or decrypt. Similarly, now to send that letter to US post office, there could be there could be some person, or it could be using fax machine, or there could be robot or something. So basically there are different procedures that are involved to send a letter from here to here, right? Similarly, same thing will happen if N has to reply back or N has to send some letter to Maria. So same thing is happening. Now there are a couple of tasks that needs to be done. One is that encryption, another is sending, another is posting it. So these couple of tasks are basically divided into different layers. Why? Because if we combine these tasks into just one single task, then it will be like, it may look that it will be simple, but debugging or doing some modification in one of the tasks will be tough. Because if I combine everything into just one layer, and if there is some fault in something, and then if I need to replace some layer, then I actually have to replace the whole thing. That's the problem. That is why it is better to divide this task into different layers, right? This is what happens in computer networks also. So suppose, let me go to the next page. So in computer networks there are different layers, and suppose that there are two hosts that wants to talk to each other, then also there are a couple of tasks that are involved. So this host has to talk to another server or host, anything. Then there are a couple of tasks that are involved, which are like that host may have to say that, okay, your server is sending some message with some speed, then host may has to say that, see, your speed is too much, just slow it down because I cannot process it. So that's called flow control. Or if server is sending some message, that message got corrupted in between, then host has to reply back that, see, that message has been corrupted and please send me back. That is called error control. And there are actually many tasks that the host and server has to communicate with each other. Like there are many tasks on which the host and server has to communicate to each other. So if I combine all these tasks in just one layer, then it will be too much. So that's why they have divided these tasks into different layers. So this is called TCP/IP suite or TCP/IP layers, where I have 5 layers. First layer is application layer, then transport layer, network layer, data link layer, and physical layer. These are the layers in our TCP/IP layers. Now you might be wondering that where are these layers in your computer, right? So if you talk about the original layers, then these are the original layers, and these are the layers in TCP/IP, corresponding layers in TCP/IP, which means physical layer is nothing but your hardware device. Data link layer is nothing but your NIC, network interface card, that is already installed in your computer or in the host machine. Network layer is just internet. Transport layer and application layer, these are related to your applications, which means internet has to just deliver that packet to your host machine. This is this is what internet does. And then after that, that packet, see, your host is here, right? Your host is running different process. This process is also accessing internet, this process is also accessing internet. So that packet will get delivered till this point using the internet. Then from here to one of the port or one of the process we need to deliver, and that is the task of transport layer or application layer. Now internet job is to just deliver that packet to the host, that is the network layer job. And then that packet will get delivered to one of the process using operating system, like operating system help or user software program. So anything could be involved in this process. So basically, this transport layer and application layer related to our application machine, and this internet is related to our network, and network interface card is nothing but a data link layer. Hardware machine is nothing but your physical layer. So there are 5 layers in which we have divided our tasks. Now what we can think of these layers, we can think of these layers as a logical connection, which means, like, if I'm sending some packet, let's suppose there are 5 layers here in the host machine, and there are 5 layers here in the server machine. If I'm sending some packet from here to here, it will go through the 5 layers, right? So what I can assume, that there is some logical connection between these layers. I mean, if this is data link layer, DLL, data link layer, this is also data link layer, then although data link layer frame has to pass through the physical layer and then to some transmission medium and then physical layer and then data link layer, but I am logically assuming that in between these data link layers there is a logical connection. This is just for the assumption, for the sake of explanation only. So although that packet has to go through the whole path, but I am just assuming that there is some logical connection between two data link layers. Similarly, there is some logical connection between two network link layers. There is some logical connection between two transport layers. Like that, we can assume. These are just logical connections, which does not actually exist in the reality, but for the explanation we will just say that transport to transport layer delivery, instead of saying the transport layer, then network layer, then data link layer, physical layer, and then it is happening. I will just say that transport to transport layer delivery, although it is happening in this way. It is happening in this way, right? Now suppose A wants to communicate to B, and there are different routers or different switch are present in the between. So suppose this is a switch, this is a switch, and this is a router, which are present in between, and A wants to communicate to B. Then at A there are different layers, because A is a host machine and it has to, let's suppose, communicate to B, which is also some machine which is having the all layers. So in this case, A will send some packet that will go through the switch. Switch just have 2 layers, which is physical and data link layer. Router has multiple layers depending on into how many links it is connected to. It is connected to 3 links in this case, but like this diagram is just having 2 layers. Otherwise, like, it should be having basically 3 layers of everything, of data link layer, 3 data link layer, 3 physical layers. But just for the simplicity, I have just shown 2 layers. But otherwise, this router is connected to 3 links. That's why it should be having 3 data link layers and 3 physical layers. Okay, if you are getting confused, then let me just remove this. Let's suppose there is no connection to C. Suppose this is the direct connection, then this diagram and this diagram are both are analogous to each other, which means this router will be having 2 data link layers, 2 physical layers, but only one network layer. Now suppose some packet is going from A to B, then it has to go through these layers, which means all the layers of A, then data link layer and physical layers of this switch, and then this data link layer and physical layers and network layer of this router, and then like this switch, and then it has to get passed to all the layers of B. This is how we communicate in the internet. So every layer adds its own header to the packet. So application layer generates a message. That message get encapsulated by the transport layer, and transport layer adds its own header, and then it get again encapsulated with the network layer. The network layer again adds its own header, then it gets encapsulated with the data link layer. It adds its own header, and now that gets passed to physical layer, and now at the destination host, decapsulation happens, which means that this data link layer packet will get decapsulated by the data link layer of the destination host. So this 2 will get removed, then 3 will get removed, then 4 will get removed. That's how the decapsulation and encapsulation works. Now as you notice that each layer, like apart from application and physical layer, each layer, transport layer, network layer and data link layer, each layer is encapsulating the packet, and the corresponding layer is decapsulating the same header, which means if 2 is added by the data link layer here, then this 2 will get removed by the data link layer at the destination host. Now there is one more model that is just a reference model, which is called the OSI model, and which says that there are 7 layers. So basically this is just a theoretical model, and that has not been implemented in the internet. If you talk about internet, the internet just have these 5 layers. This is just a theoretical model which never got implemented. It was just proposed. So basically there are 7 layers in the OSI model. It says that like these were the earlier layers. It says that we also have session layer and presentation layer, which has some tasks and which are basically in TCP IP model, which these tasks that are done by session layer and presentation layer, these tasks actually got merged with the application layer only. So application layer handles all of this in the TCP IP model. So if I compare OSI and TCP IP, then I will say these 3 layers got combined into one application layer in TCP IP, and this is the OSI model, which is just a theoretical model. You do not need to know about it, but yeah, these layers are important, and we will be studying every of this layer in the detail. Now before we study all of these layers in the detail, let me introduce you to few terms which are like bandwidth, throughput, delays and these things, so that we are very good with these terms whenever they are getting used in the layers, because in almost every layer these terms will get used again and again, like what is the bandwidth of the channel, what is the delay that we are facing, like that. So the bandwidth of the channel is just the capacity of the channel, which means suppose I can send, suppose this is the channel, and I can send the data with the speed of 10 Mbps. Then I will say the bandwidth is 10 Mbps. But I mean it is just a potential speed, which is like which is I can send, but I may not always be able to send, which means suppose the channel can hold 10 Mbps, but the ending point, or there is some intermediate point that is connected to this channel, which says that see I cannot process the data with the 10 Mbps, so please slow down. So in that case, suppose I can only send with 1 Mbps speed. Why I'm sending 1 Mbps? Because this connecting device, this device is saying that see, I'm the intermediate device, or I may be the end device, but I cannot handle, or I cannot process the data with 10 Mbps speed. So I can only handle the data with 1 Mbps speed. So in this case, this like bandwidth will be still 10 Mbps, but the actual speed of the data will not be 10 Mbps, even though the bandwidth is 10 Mbps, and that is called throughput. So in this case, throughput will be 1 Mbps even though bandwidth is 10 Mbps. So bandwidth is the actual speed or actual transmission rate on which we can send the data, but it may not be always possible because of many reasons, and that is the practical what we are getting is called throughput. So generally, I mean not generally, always throughput will be less than equal to bandwidth. Obviously it cannot increase, like it cannot be greater than bandwidth. I hope you got the idea. So bandwidth is the ideal or potential speed on which we can send the data, but throughput is the practical speed on which we are actually sending the data. Yeah, throughput is clear, which means if I have one channel and there are two devices or multiple devices that are connected to this channel, let's suppose A and B, and I want to send some data from A to B. So in this case, it will depend on the speed of A and the speed of B. Suppose like this channel can handle the data with the speed of 100 Mbps, but this A cannot send the data with the speed of 100 Mbps. Suppose A can only send the data with speed of 1 Mbps. Then in this case the throughput will be just 1 Mbps, and suppose B can handle the data with 1 Mbps, then the throughput will be just 1 Mbps, right? So throughput is basically the practical or the in real life what speed we are getting, or at what speed we can send the data. This is the throughput. Bandwidth the ideal speed that the channel can handle. So bandwidth in this case is still 10 Mbps, but the throughput is just, or 100 Mbps, but the throughput is just 1 Mbps. Let's take an example. A network with a bandwidth of 10 Mbps can pass only an average of 12,000 frames per minute. So what they are saying, that network has a bandwidth of 10 Mbps, 10 Mbps. So in computer networks, this kilobytes or kbps means, like generally if you are talking about the computer, it is 2 power 10. If you are talking about like if you are talking about the computer network, so this data, the data speed will be in 10 power 3. So whenever I say 1 kbps, it means 10 power 3 bps. Whenever I say 1 mbps, it means 10 power 6. Whenever I say like 10 power 6 bps basically. So 1 mega is equal to 10 power 6 and 1 giga is 10 power 9. 1 kilo is 10 power 3. This is in computer networks, but in operating system, whenever I say like your file size is 1 mbps, so in this case this 1 m will be if you're talking about the operating system, that your file size is 1 mbps, it will be 2 power 20. And whenever I say your file size is 1 gbps, sorry, 1 gb, not gbps, your file size is 1 gb, then it will be 2 power 30. And 1 kb, then it will be 2 power 10. So this is your file size. But if I talk about the speed or anything, then I will go with these numbers. If I talk about the file size, then I will go with these numbers. Okay. Now what they are saying, the bandwidth, if I say bandwidth or delay or these things, then it will be just like I will take this mega as 10 power 6. So bandwidth is 10 mbps, means bandwidth is 10 into 10 power 6 bps, and now can pass only an average of 12,000 frames per minute. So in a minute I can send 12,000 frames, which means, and one frame is carrying 10 power 4 bits. So which means in a minute, in 1 minute, I can send 12 into 10 power 3 into, in 1 minute I can send these many frames, which means 10 power 4. In 1 minute I can send these many bits, which means my throughput will be these many bits per minute. But suppose I want in seconds, so I will divide with the 60 upon 60. So this is my bps, so these will be bps, which means bits per second. This is my throughput and this is the bandwidth. So if I calculate the throughput, which is 12 into 10 power 3 into 10 power 4 upon 60, then it will come out to be how much? And what was our bandwidth? So bandwidth is like have no use in the calculation of the throughput. The bandwidth was 10 mbps. So I had the bandwidth of 10 mbps, but the throughput of only 2 mbps, which means the actual throughput or actual speed on which we can send the data is just 2 mbps. which is just 1/5 of the bandwidth, right? So here we have the solution. Now let's see the delays in computer networks. So there are different kind of delays. Suppose there is one machine that wants to send the data to another machine, and there are different routers and like different switches in between. Now there are like two delays which are important. One is propagation time, another one is transmission time. So what are the propagation time and transmission times are? So propagation times means whenever we are sending some packet from here to some host, let's suppose this is a host A, this is a host B. Whenever we are sending some packet from A to B, then the time to travel one bit, time to travel one bit from A to B is called propagation time. So just a time to travel one bit from A to B. So generally like we send multiple bits, but I'm just saying suppose it is just sending only one bit. So the time to travel just one bit from A to B is called propagation time. And transmission time is that time to put, suppose this is your channel and this is the host machine and this is your packet. So transmission time is that time to put the whole packet on the channel is called transmission time. And queuing time is that suppose there are some router or some devices in between, then like generally they do not directly send the packet. There are like queues on the router. If there are any congestion, if there are multiple packets that are lying up, so it will store those packets in the queue and then it will send one by one. So or like till how much time it is storing the packets in a queue is called queuing time. So generally this queuing time like we cannot determine, so I will not use this in my calculation because this is the time that we cannot determine, which means like I mean it depends on the router. Basically sometimes if there are more congestion then the queuing time is more, if there are less congestion then queuing time is less. Generally like these times are very less, so we will just ignore this time. And processing delay is that if there is some intermediate router or intermediate switch or something, then they need to also process the packet. Like router generally has to check on look in the packet that to which interface it has to forward the packet, right? So these times are called processing delays. So we will not talk about this processing delay or queuing time, which are because these are not I mean these are not parameter dependent, so we cannot measure them. So we will be just talking about the propagation time and transmission time. Now let me talk about the propagation time and transmission time in more detail. So propagation time is the time that measures the time required for the bit to travel from a source to destination, which means this is the source, this is the source A and this is the destination B. Then if source is sending like it generally sends multiple bits, but let's suppose source is just sending one bit. So even though it is sending multiple bits, it doesn't matter. So I'm just talking about the one bit. You can take any one bit, okay, any one bit. So in this packet you can take any one bit. So let's take the starting bit. So the time to travel this one bit from A to B is called our propagation time. Now this is very simple. I mean to calculate the propagation time we just need to divide by the speed, because if we know suppose the distance d and suppose the speed is v, so it will be propagation time will be d upon v. Very simple, right? So I hope you got the idea. Let's do one question about the propagation time. Here is a question which says that what is the propagation time if the distance between 2 points is this much kilometer? Assume that speed is this. So what I need to do, I just need to divide this distance by the speed, which is 2.4 into 10 power 8. So 50 millisecond. 50 millisecond is the propagation time. So which shows that this example shows that a bit can go over Atlantic Ocean in only 50 millisecond if there is a direct cable between source and destination, which means like Atlantic Ocean is one of the largest ocean in the world and which is like huge. I think this will be of 12,000 kilometers or something. So if there's a cable between two endpoints of the Atlantic Ocean, then we just need to wait 50 milliseconds, which is just a blink of eye. In that you can travel, you can send your data from one end to another end, because the data speed is also almost equal to the light speed, which is 2.4 into 10 power 8. And that's where the optical fibers are helpful. So in the optical fibers the speed of the data is too much. Now let's talk about the transmission time. So transmission time is a time to put the data on the link. Time to put data on the link. which means suppose this is A, this is B, and then A has to send multiple bits to B, then A has to put this data on the link, right, first, and then this data will get travel to B. So the time to put this data on the link is called the transmission time. So obviously it will depend on the data size or the message size, and it will also depend on the bandwidth, because bandwidth is one thing which determines capacity of the channel, which means suppose bandwidth is 10 Mbps and message size is, let's suppose, 10 KB. So message size, length of the message is 10 KB and the bandwidth is 10 Mbps, and we want to find out the transmission time. Transmission time generally we represented TT is equal to length, which is 10 KB, upon MB, right? So this is the 10 MB, which means 10 is power 10 into 10 is power 6. This is 10 is power minus 3 seconds, which means 1 millisecond. So in 1 millisecond, this A can put the data to the link. Now suppose if they say that length is 10k capital B, which means kilobytes in this case, and bandwidth is still same, which means 10 m small bps. Okay, this is small b, which means 10 bits per second. It is 10 kilobytes. So length of the packet is 10 kilobytes and bandwidth is 10 m megabits per second. So transmission time will be length, which is 10 into 10 to the power 3 into 8. Why? Because we need to convert this bytes to bits. That's why I'm multiplying by 8 upon 10 is 10 into 10 to the power 6, right? And now everything is in bits. So you can cancel out this 10 to 10 and it will be 8 milliseconds. So it is 8 millisecond transmission time. I hope you got the idea. Now let's solve this question. What are the propagation time and transmission time for 2.5 kilobyte? Now this time they have given in kilobytes message if the bandwidth of the network is 1 Gbps. So length is 2.5 kilobytes. So let me convert it into bits. 2.5 into 10 to the power 3 bits, and bandwidth is given to be 1 Gbps, which means 1 into 10 to the power 9 bits per second. It is also in bits. Assume that the distance between the sender and the receiver, so distance is given to be 12 into 10 to the power 3 kilometer, and let me convert this into meter because the speed is in the meter. So 12 into 10 to the power 6 meters, right? And the speed is given to be, velocity is given to be 2.4 into 10 to the power 8 meter per second. Now they have asked propagation time and transmission time. So let me find out the propagation time, which means the distance upon velocity. So distance is this and velocity is 2.4 into 10 to the power 8. These much seconds will be your propagation delay. So it will be, you can just put 10 here and 12 into 2 is 24. So it is 0.5 into, this will be 10 to the power minus 1, which means 0.05 seconds, which is also equal to 50 milliseconds. Now what will the transmission time? It is basically the time to put the message on the link. So it will depend on the length of the message, which is 2.5 into 10 to the power 3 upon the bandwidth. Bandwidth is 1 into 10 to the power 9. So it is 2.5. So you can just put 10 here. So it will be 25 into 10 to the power minus 7, which means 2.5 into 10 to the power minus 6 seconds, right? Okay, I think we need to also multiply by 8 because this is byte, so I need to multiply by 8 everywhere. This is into 8 and into 8, so I will be getting into 8. So this is transmission time we are getting is 2.5 into 8 into 10 to the power minus 6 seconds, which is basically, if you multiply by 8 you will be getting 200, right? 25 into 8 is 200. So it is 20 into 10 to the power minus 6 seconds, which is I think 0.020 milliseconds. So this much less time we are having in the transmission. So as you see here, the propagation time is too much, which is 50 milliseconds, and the transmission time is too less, which is 0.020 milliseconds, which means if you if A wants to send the packet to B, then it is taking only 0.020 milliseconds to put the data on the link, but the propagation time is too much, which means 50 milliseconds. So 50 milliseconds we are taking to travel from one bit of the packet to the other end. This is 50 millisecond, and we are just taking 0.20 milliseconds for transmission time. Now let's solve this question. What are the propagation time and transmission time they have asked in this question? So we can solve this question using the same method, and I have given the solution here, so you can just try it out without seeing the solution. That's very easy question.